to know. Put this in silencer mode. And that's why I want to log into my laptop as well when it comes to that, because I have the resource pack on Windows on my laptop. Okay, so we talked a lot about the classification matrix last time. And remember, thank you very much. We have training data and we have validation data. Which one do you think is better to look at? Which one has better data? The classification matrix of the validation or the classification matrix of the training data?
Of the validations.
Why?
You're validating a model.
That's correct. See, the training data is the confusion matrix, the classification matrix, that goes along with the training data is very biased because, and the errors associated with that classification matrix, with the training data, will be very small. Whereas the validation data was not used to generate the model, it's used to validate the data. The errors will be bigger with the validation data, but they're more unbiased. They're more trustworthy. Okay? We talked about the various accuracy measures. We talked about the overall accuracy. As you see, I had taped this before, and I lost all the videos. They lost them for me. We talked about the naive approach, and we talked about the cutoff point last time. So this is the data that we worked with last time, and I did it manually. So and I used this Excel file, which is what I wanted to do last time. All right, see how lovely it is when you have something that's working. You don't know how many people I yelled at. And also Anthony helped us get this. It's unbelievable. You know what I told them? I told them, and I love IT because I'm an IT person, that I have been to a kindergarten school that had better computers than I have. And it is true. I went to a kindergarten school in Revere, and they had better kindergarten, better computers, better blackboard. And I said, what is going on? I'm fighting for you. I also can't help it. It's my personality. It always lands me in trouble, but I love to be in that kind of trouble. Anyways, so this is the data. You have the actual, these probabilities are generated by somebody, we don't care at this point. And if the cutoff point is 0.05, all right, by the way, I have this Excel file, and whenever somebody tells me that they know Excel very well, I tell them, do you know how to use the index function? Do you know how to use the offset? And do you know how to use a combination of count, offset, and index? And they say, what is that? I said, you don't know Excel. You don't have to know them, but if you say to somebody, if you go to an interview and you don't tell somebody you know Excel unless you know it very well. Logging into Excel does not mean you know how to do it Excel. All right? You can do incredible things. Okay, so this is the, move this out of the way. So this is the cutoff point, 0.5. I automatically, using the index function, I generate the location. You see 13? 13 is this index right here, the location of the first row above 0.500. I'm not going to test you on knowing index offset, okay? This is, so, and then this tells me that I'm using at the array from 1 to 13, so I'm looking at this guy right here, all right? So here you're supposed to have mostly ones because you sort the data by this probability. You can see these numbers, right? Okay, you can see these numbers? All right. So you sort the data by these probabilities that the classifier produced. These are the predicted values. So what we're saying, if there's a probability greater than 0.5, anything above is assigned to class 1. So from these, this in blue and this in red, you can generate this classification matrix with 0.5. So what I do here, I dynamically generate the true positive using Excel functions, the false positive, the false negative, and the true negative, and then I plug them into here. Then I say, for example, this guy is this 11. This 2 is this 2. If I change this to a 0.75, then it generates the, so automatically, dynamically. All right, you don't have to do any counting. So I can change the cutoff point to anything I want. Last time I asked you to do the 0.80, all right? And here is, the 70512 that I generate using the index, the sum offset, blah, blah, blah. If you want to become good at Excel, I always want to do a workshop on Excel, these types of commands. There's just too many things. There's not enough time in the day. And I put them here. Now, you see here, I generated this table, which I'm going to do here. So I will take, this is what I want to show you last time. Take this, and under here, I have all possible cutoffs between 0 and 1. Okay, like that. You create this. Then you see this, then up here, I will generate the overall accuracy from this classification matrix, and then the error, which will be 1 minus the accuracy. We did those last time. So the formula here is this. So the, all right. So here, how do I generate the overall accuracy? This is the true positive plus the true negative divided by everything. This plus that plus that plus that, okay? So the overall accuracy, you see this right here, is, now see this is using the whatever I had. What did I use? Let's change this back to 0.5. It doesn't matter which one I use, 0.5, so you see that that's going to change, right? And this is the overall error, which is 1 minus the overall accuracy. So let me paint this table right here. By the way, I can do this in Jump or anything else, but I want you to see it in Excel because I do all the detailed stuff that Jump does behind the scenes. By the way, how many of you watched the Monday night football game? You did. What are the two guys? Collinsworth, who's the best in NFL in terms of explaining the game. What was the other game? I know the other guy. What's the other guy's name? Al Michaels. Actually, Al Michaels, I admire that guy because he was doing a baseball game in San Francisco and there was an earthquake and he kept millions of people calm. Al did a fantastic job. Anyways, they spent about 4 to 5 minutes talking about sports analytics. And they showed there was two Chinese guys doing sports analytics for one of the two best football teams. Did you guys see that? Anybody? They say they're doing analytics, right? And so it will become more and more prevalent. The analytics, the AI, the data mining, and I'm trying to get a sports analytics program get started here. There's a tremendous input, and the communications department heard about it, and they're going to come and meet me, and you see the flyers that I've invited the VP of Analytics from the Red Sox. I would, if I dreamed all my life to work for a sports team, and it's too late now, but if you love that environment, and I looked last night how much money the people that announce the games do. So if you have a talent in explaining, describing the game, and you understand analytics, their salaries go anywhere from $1 million to $30 million. Something in Rome, one guy, he makes $30 million. Okay, and the ladies, they don't get much money as the men, and they deserve, right? And they get anywhere from 200,000 to 4 million, right? So if you have a knack for explaining the game and you understand analytics, right, you can make millions. Yes.
But can't anyone just read charts and figures? Like it's not like they're doing the analytics. The people announcing the game.
Right, but correct. They don't do analytics. But if you have the knack to explain the games and you understand the analytics, you can go to 10 million, 20 million, $30 million. And some people have that, right? So analytics will help you in so many ways. Okay, so what you can do next is this, and I have the steps. This is called the one var Excel table, all right? So when you have, the cutoff point is 0.5, this is the accuracy and this is the error. And you can calculate the accuracy and the error from here. What about if I wanted to do this for all the different cutoff points? I don't want to have to do them one by one. So what you do is this. See, everything is driven by the cutoff point, which is 0.5. This is the driving force. So what you do is this. You select, the reason I colored it, you select this green area, all right? Then you click data, then you go to what if analysis, then you click data table. I have the steps here. Then I click data table here. And then you go to column input cells because the cutoff points are in a column. And I click the cell that has the cutoff point 0.5. And then I click OK, and froof, you get the, for all the cutoff points, you get the corresponding, all right? And why are we doing this? Okay, so once I have this, I want to produce this graph. Because I want to find out which is the best cutoff point. So then once I highlight this, I click Insert, and then I go to Recommended Charts, and one of the graphs is this, all right? Okay, there's a reason why it has that, because I'm using this 0, 0, all right? So let's ignore that. Let's just keep these guys only. So Insert, Recommended Charts, I click this. So this is what I have here. And of course you can change the all right. What is this? I did too many of these. Okay. Now, you see the orange is the error. The blue, didn't want to have that one. The blue is the accuracy. So you want to look at the maximum combination, and you see that when you have a 0.65, you have the maximum accuracy and the minimum error, which I had a vertical line here somewhere. Which happens about here. This is the maximum accuracy, right? And you have the minimum error. So the best cutoff point is 0.65. And this could be used if you were dealing with cancer versus no cancer, right? You want to maximize success being detecting cancer, right? So I wanted to show that to you. There is a 2-var table in Excel, but I'm going to skip that. So that's what is described here as well, and there is help on that. All right. So now, why would I want to increase the cutoff point, or why would I want to decrease it? Insurance companies do a lot of that. You see, this is the graph that I generated. Okay? So this is figure 5.4 from the second edition of the book. It may have another number in the new edition, but I like the notes from the previous edition. These are the steps describing how to do this one variable table in Excel. But if you just read that, it may not be too clear. Okay. I want to next talk about the ROC curve, Receiver Operating Characteristic Curve. Now, these are very important items. Remember we talked about TP. TP is very important because during a test people confuse TP and TPR. TP is a count. So this says you had 201. If you have 3,000, let's say that 1 is cancerous and 0 is not cancerous. That means 201 out of the 3,000 people who were actually cancerous, they were predicted to be cancerous. So TP is to TO1. TPR is a fraction. TPR is out of all the positives, what percent was classified correctly? When I use the word classify, it means predict. Okay. Now let me try something. When you print, and you want to print, they took that out. Oh, see more, no? If you print to one note, let's see if that works. If you print to one note, you can go and annotate that. And let's see if that will work for us. While we're waiting for that, paint. It is beautiful that you have, when you have a new computer, so we take certain things for granted. So, fantastic. Now, you see TPR is you're looking at all the truly positive, all right? So TPR is TP divided by TP plus FN. See, these are all truly positive, right? These are all people, for example, that, so plus, which is the same as 1, means cancerous. Okay? So, that is, so, success is detecting if somebody is, has cancer, right? So when we say success, is not always associated with something good. But success from the medical point of view is identifying somebody who is cancerous and that you can start treating them. Okay, so 1 is success, 0 is failure. So, but failure in this case is identifying somebody as not being cancerous. This is negative, okay? So you have to go with a definition regardless of what is good or what is bad. We're not looking at that. Okay, so TPR would be 201 would be here, 201 over 3,000. I'm sorry, 201 over, what is the total here? 286. So sorry. Over 286. That's TPR. So TPR is called sensitivity, and there's another name for it, which is recall. You have to know all of these names. You have what to study for the midterm. The topics are already on Blackboard. And I hope that you have seen it. here. Topics to study for the midterm, topics 1, topics 2. Everything here. These are the topics to study for the final. All right? And the date of the midterm is October 17th,
Next Thursday.
next Thursday.
Professor?
Yep.
How is like the format of the midterm? Is it gonna be like
Anything is possible. You can expect multiple choice, fill in the blank, questions, definitions, problems. Do not study around the type of an exam. This is a big mistake that you're all making. Study by learning the topics, and then the format of the exam does not matter. Yes?
Will you give us jump output and then ask us to?
I will not ask you to log in and do something with Excel or with Jump or with any software, but I can give you the output, and you need to know how to interpret it. The exam will be closed books, no notes, nothing like that. You will be given no formulas, nothing. The final will be all multiple choice. And I want you to know this up front, and I think I have it in the syllabus. That's because I will correct the final, the midterm, not the TA. And for the final, and it takes me a long time to do it. A long time, because I take the time to do it. And for the final exam, we have a couple of days to correct the exams and submit the grades, and I don't have the time to correct them properly, and that's why I do it multiple choice. So that is the plan. Yes?
Should we focus on the two files, like topics 1 and topics 2? Or?
That has all the topics.
Okay,
Yes,
so both.
that has the topics, exactly. Which means you got to do all the reading in all the chapters in the book and the documents that I cover in class. Okay, but I will talk more about it this Thursday. No quiz this Thursday. All right. So, all right. So, the recall. Specificity is TNR. Whenever you see R, it's a rate. Rates are between 0 and 1. All right? So for TNR, you take the proportion. Here, they're all, in reality, they're all negative. Negative, all right? They're all negative, right? So TNR would be 2689. So TNR would be 2689 over 2689 plus 25. I want to prepare you for real life, because when you go to the real world and you say, I'm sorry, that project is too difficult. Well, they will tell you, go home, I'll find somebody else who will do it. That's real life. Okay, and I want to prepare you for that. Okay, that's TNR. Now, one minus TPR, one minus TPR is called FNR, the false negative rate. And the false negative rate is the false negative rate is Fn, okay, over observed positive, which is basically true positive plus false negative. The same denominator as TPR. FPR is 1 minus specificity. So this is FPR. Okay, FPR. FPR is also FP over FP plus TN. Okay, So you have these four rates. And the reason I'm discussing those two, and I ask you to watch two videos on sensitivity and specificity, those are excellent, okay? Because specificity and sensitivity, they go in opposite directions. And those videos talk about that. So if sensitivity goes up, specificity goes down. If sensitivity goes down, specificity goes up. I wanted to show the receiver operating characteristic curve, and I need to download that real statistics resource pack, and I have to have special privileges on this to do it, which I don't have to download something locally, and that's why I brought my laptop. And I need to connect via NU Wave guest with this because I cannot connect as a new wave for some peculiar reason. But you need to know sensitivity and specificity, right? Now, when you use the confusion matrix, we have two outcomes, success and failure. All right? Success and failure. But you can have more than two outcomes. You may have, for example, in your case here, we have freshman, sophomore, junior, senior. You can use a confusion matrix with those four outcomes. So you can be a freshman and be misclassified as a sophomore or a junior or a senior. You can have that kind of confusion matrix where you have more than two outcomes. Now, in many cases, it is more important to identify members of one class, like this, tax fraud, credit default, all of these things right here. Identifying somebody as being cancerous or not, right? And let me use the example of cancer because it resonates with people. It is crucial to identify people who are cancerous so that you can treat them. This is supposed to tell me when I try to connect that to do as a new wave guest, you need to it needs to call my telephone for some reason. Okay. And so when you have scenarios where it's more important to identify people in one class, right? You're even willing to to make a bigger error, to have a bigger error in identifying people, for example, who are cancerous, in identifying terrorists, right? So, for example, in the airports, if it's going to cost $10,000 more to find a terrorist, it's worth it because the consequence of not finding that person is that people die. And the same thing, which was used in World War II, you want to identify a plane as being friendly or enemy. You will not consider the cost associated with that type of classification. In those instances, using the ROC curve, okay, is the way to do it. And in those cases where the overall accuracy does not help you, right, in evaluating the classifier, you don't care what the error is, right? What the overall accuracy, the accuracy may be, in fact, it will be, it may be small. The error may be big. So in other words, if you look at the next 2,000 people in an airport, and you want to find the people who are either terrorists or not terrorists, right? I mean, if you try to identify people who are terrorists, your accuracy will be very low, because you look at many people, and most of them, 99%, will not be that. So this is where ROC comes in. And that is where we need to have this sensitivity and specificity. The wording confuses the heck out of people, and I want us to understand the terminology. I'm opening up different sessions so that I have all the places where I annotate. Okay. Now, sensitivity is the percent of C1. This means class 1. One is when class 1 is when somebody is cancerous. Okay? It says the percent of C1s, C1 class correctly classified. So see, this is in the beginning, it's confusing a little bit as to what that means. C1s correctly classified means that you know that you are in class 1, you know you are cancerous, and then you either predict that they're cancerous or you predict that they're not. So sensitivity is the proportion of plus plus, which is true positive, over plus plus and plus minus. That is sensitivity, the TPR. So this sensitivity is the percent. This is a percentage here. This is a percentage. Okay? So this here is a percentage. All right? Is a percentage of class 1. Class 1 means you have 1 and 1. You have plus and plus. Correctly classified, correctly predicted. Well, correctly predicted is when you have plus plus. This is at the denominator. You have correctly predicted pluses and incorrectly predicted pluses. Right? So pay attention to terminology. Specificity is the percent of negatives, of zeros, correctly classified. So here, see, in both instances, you know that you have negative as 0, and you want, this is zeros correctly classified, 0, 0, and these are zeros or negatives classified as positives. So specificity is when you have negative negative over a negative positive. This is the FP, the number FP, plus negative negative. So this is TN right here, right? So, all right. And then you have false positive rate is the percentage of ones, positives, that are classified well, false positive rate is in reality you have negatives, but you classify them as positive, and false negative rate is positive classified as negative. That's what the wording here means. Okay? You have to be on your toes when you are working with this. Okay. And then you have positive predictive value, which is I'm testing this new computer with everything that I can to see if so far it's behaving properly. You see, when you do the confusion matrix, you have a true positive here, then you have false positive, and down here you have the predicted positive, right? So you have the positive predictive value. So this positive predicted positive value has been, now remember this is the actuals, right? And this is predicted up here. And you have this, that, this, and that, okay? So you have true positive, false negative, and true negative. Okay, so this is true positive over predicted positive, okay? So here is the proportion of positives that this is the proportion of positives that was predicted properly, okay? So here you're looking out of all the ones that were classified as positives, right? What percent is truly positive? TPR is out of all that were actually positive, right? You see, this is positive, positive, and this is positive, negative. When you do TPR, is the proportion of all of them that are truly positive, right? And when you find the positive predictive value is out of all the predicted positives. Where is this thing? Where are you? Okay. Out of all the predicted positive, which ones were truly positive? And the negative predicted value, okay, and the negative predicted value is out of all the predicted negatives, which proportion is truly negative, right? Okay. Okay, everything is here. Now, so this is explaining the sensitivity or recall. Whenever you see 1, 1, that's positive, positive. 1, 0 is positive, negative, all right? 0, 0 is negative, negative. 0, 1 is negative, positive. So, in the beginning, they were plotting. In the beginning, they were plotting oops, another line. they were plotting specificity, okay, on the x-axis and sensitivity on the y-axis. And what happened, as the relation between the two was like this. So the relationship between sensitivity, or TPR, and specificity is this. If one goes up, the other goes down. Right? And instead of plotting these two, they decided to plot instead sensitivity on the y-axis and 1 minus specificity on the x-axis, or FPR. And this now, and we'll talk about this. This now, the curve goes like this. Okay? This is the receiver operating characteristic curve, and that is this thing doesn't help me. I wanted to show you the real statistics resource pack, and let's see if I need, in order to do that here, I need to have the ability to do something with the C drive. And I don't think I have the ability to do that here. Okay. Now up here, I actually have the steps. Let me. I don't want to spend too much time because I can do the whole thing in Jump. So, let's say that you have a Mac. You've downloaded VMware and Windows. I have Windows here, obviously. You can log in as on the Mac as Windows. Go to the control panel. You can do that on your laptop. And then you go to appearance and personalization. It's good to know to do that on your own laptop as well, because there are folders and directories on your own laptop that by default you don't have write access to. You can't save files into, and this is to protect you. So if you click appearance and personalization, under the file explorer options right here, you click show hidden files. Show hidden files and folders. You do that. Then you go down, all right, and you go under where it says hidden files and folders, and you click show hidden files and folders, and then click apply. Oh, okay. Click OK. Maybe they gave me more privileges so I don't yell at them. Let's see. Okay, so I'm following these directions. To simplify things, because there's other things, to simplify things, I copied one way to become very rich is to create your own software company. You don't even have to know to do programming. You have an idea. You can create an Excel add-in. And when you create an Excel add-in, you write Visual Basic code, and you create a file that will call something .xlam, and then you sell it. You say, for example, Excel doesn't do this. Okay, the guy that wrote this, he made a lot of money. He taught, and then I don't know, he invested, he made a lot of money. And the guy that is in the real statistics, that has the real statistics resource pack, and he's doing that for free. So you don't have to get this. But what I'm saying is this. Here, right click on this. Do not try to open it. Right click, and then do save as. And then I tell you where to go. Right? Go to see users. I'm going to go for Yaris, app data, roaming, Microsoft add-ins. So I go to see, right? Users, then you pick your name. Here's where I am. App data, roaming. I'm surprised that I can do this here because I tried to do this on the desktop computers before and it wouldn't allow me. You go to roaming. I always forget what's after roaming. Microsoft, here, add-ins, and you save that file there. Oh my God. So, see users, right? For Yaris, or your own name. What was it? App data. Oh, there it is. It may not show it to you right now, but it's there. App data, roaming, Microsoft, add-ins, and here's the file that I downloaded. But I had to enable showing these folders. You have access to your computer to do that. Ordinarily, I don't have that access here, but somehow I have. All right. So, now, you may have some issues if you have a Mac or even if you have a Windows, but let's see. I want to then go into Excel. I want to open Excel. So let's see if we have Excel here. Okay, good. Go into Excel. By the way, upgrade the operating system on your Mac. Upgrade to Office 365. Otherwise, you're going to have many problems and you will blame the software or somebody when the problem is that you don't have the latest operating system version. Well, okay. So here I have, if I go to File, Account, About Excel, I know I have Microsoft 2016 32-bit. You may either have 32-bit or 64-bit, and it tells you the version, 16, so it's good to know that. I want to go to Options and click Add-ins. If you click Add-ins and you go down to where it says Inactive, so you here you have Active and you have Inactive. You will see this X real stats. That's the, see Excel looks in that folder where we save this file to, and it says if it has XLAM files there. Okay? Then I click where it says manage, I click here and I click go. This thing comes up, I want to check solver adding and X real stats and click OK. And I actually want to click analysis toolpack. I click OK, and you will see next a thing show up here, a group. If I click data, I see the data analysis toolpack, right? That shows up there, and if you click that, that allows you to use certain things. But more importantly, if I press Control M, oh my God, it worked. Control M, this thing shows up. Okay, that means you have put the real statistic resource pack as an add-in in Excel. Did you guys, is this working for you? If you don't have the latest Mac operating system, if you have Excel version 2013 or something like that, you're going to have issues one way or another. All right? Did this work for anybody? It's working for you? It is very important to upgrade your software to the latest. Otherwise, you're going to have peculiar things. Okay, but I want to show you this. Even if it doesn't work, I want to show you this because now I want to open up, I think it's this file. Yep, that's the file. Okay. Yes.
It's asking me for a password.
Click cancel. I expect that problem. If you just click cancel, things may still work. So click cancel, don't put a password, and then just press Control M. Or on the Mac, press Command M. Does the thing show up?
Like, it minimizes the screen.
So when you're here on Windows, actually if you're logged in as Windows, if you press Control M, you should see this.
I didn't
Huh?
I don't have VMware, but I saved.
You don't have VM, do you have a Mac?
Yeah.
Okay.
But I
You
don't-
need to be installed, you need to be logged on to the Mac. On his website, it says that it works for the Mac too. But I can't guarantee with that.
Okay.
There's other issues as well. If you have 64-bit or you may not have the latest Excel. There's like 10,000 different reasons why it may not work. Just look at what I'm going to do because I want to do this using jump afterwards, right? But I want to show you how doing it this way and then doing jump, I get the same, actually not almost, the same exact thing. Okay, so, okay, so now here, I want to go over an experiment and here is the experiment, okay? Here's the experiment. You have a spray that you want to use it to kill mosquitoes. And you have altogether 806 mosquitoes that you have invited. You say, come over, we'll have lunch. So you trick them. And then you take 37 mosquitoes and you give them a dosage of less than 2 milligrams of that, okay? And you see out of those 37, 34 lived and 3 died. Success is when a mosquito dies. Means the spray is working. Failure is when a mosquito lives. Then you take 70 mosquitoes and you give them a dose of milligrams, right? You say, open your mouth, plop, you throw the pill, some die, some don't. Out of 70, 63 lived and 7 died. So you keep increasing the dosage, right? and you write down, so for example, here you give a dosage between, the dose between 12 and 13.99 milligrams. You gave it to 84 mosquitoes, 9 lived, 75 died. So it's, aha, okay, more and more success. Okay. And then the real statistics resource pack, you'll see how we input the data, produces this output, a classification matrix, and then also a nice graph. So let's do this, because I want to show you how the numbers are calculated. Okay. Now, these are the different dosages. I specify a cutoff of 10. And these are the actual results here, observed or actual. So you have 37 mosquitoes, and green means they lived, and this means they died. So if the dosage is between 4 and 599, 88 mosquitoes out of the 99, 88 lived and 11 died. 88, so you have 88 failures, 11 successes. Okay, now, this is the cutoff point. Okay, I put it, so this is 10, and now keep in mind, these numbers go from smaller to larger. Sometimes they have them from smaller to larger going up. All right, now, if I look at these numbers here, right, the total is 413. These 413 mosquitoes, in reality, they lived, right? The prediction is that if mosquitoes, if the dose is less than the cutoff, the mosquitoes will live. So these 113, in reality, they lived, and the prediction is that after they are sprayed, that they will live as well. So this 413 is negative negative or true negative. Therefore, the 413 goes here. Actual, success, or you put success died, failure lived, and predicted, success died, okay, success and failure. So the 413 is lived and lived. In reality, they lived, and we predict that they will live. If you look at this, in reality, they lived. But the prediction is that all of these will die because the dosages are above the cutoff point. So these are negative plus. The total of all of these is 114. In reality, they lived, but they died. So this is negative positive, which is false positive. That's why 114 goes here. If you look at these, in reality, they died. But because the dosages are less than the cutoff, the prediction is that they live. So it's die, live, which means plus minus, which means positive, negative. The total here is 58, so that's going to go into here. Positive, negative. Actual positive, predicted negative. These, in reality, they die. But because the prediction is that they will die also because the dosages are above the cutoff point. So this is die, die. Right? The total here is 221, and that's true positive. Die, die, plus, plus. Poof. Now, as part of the output, the resource pack, these are cumulatives here, it generates the FPR, the false positive rate, and the TPR. These are the two numbers we need to do the resource operating characteristics curve. Now, if I look if I look here, I think it gives you two of these numbers. From here, I can generate the TPR. The TPR, I can do it myself, is 221 over 279, which is 0.79. And that is here. This is FPR. Well, I can generate the FPR directly, or I can find TNR. TNR is TN over TN plus FP. So the TNR is 0.78. So if I take 413 over 527, I get 0.78. Therefore, FPR is 1 minus that, 0.216. Also, this software, I brought my laptop because in the past I had problems being able to do what I showed you. I'm glad it worked. Okay, the software will also give you this graph. This is the resource, this is the ROC curve. This is very important stuff. Okay, and the combination, see, this is FPR on the x-axis, false positive rate, and this is TPR, the sensitivity. At the cutoff point of 10, this dot corresponds to the combination of FPR and TPR that we get when the cutoff point is 10. So, now let me show you how we use the product to generate this. So, I take you see the dosages right here? You have to take the data. So this represents 0 to 2, 2 to 4. You have to enter the data this way. So let me take the data and put them in a completely brand new spreadsheet right here. All right, that's the data. Okay. Then I press Control M. Then I double click ROC curve and classification table. Input range is, I select this, I think. It has, how many of you have taken, you don't have to remember that, but how many of you have taken calculus for business and economic majors? You studied the trapezoidal rule in that class, and this is what's used behind the scenes here. So I don't have to pick it, but the cutoff point is 10. The output range, I want the output to appear somewhere starting there, and I click OK. So that is what the software generates. Okay. And okay, so you did this, you see, with a cutoff point of 10, all right, and by the way, I can have more precision here. There you go, like that. Whenever you deal with the probabilities, it's good to go to 4 digits of precision. So if I go over this point right here, right, so this is, I just moved the cursor over. This is 0.21 and 0.79. The cutoff point is 10. This is the 0.21, this point, the 0.79. It also generates something called, this is area under the curve. The area under the curve, see, this is the curve right here. And so this is the curve. All right. The area under the curve is this. Area under the curve. This is right here. You have, actually this is a square. You have this square. Remember here you have false positive rate. Here you have true positive rate. All right. And this is the area over the curve, right? Now you have 4 very important points. Let's call these points A. This is the point 0, 0. Let's call the point B. This is the point 0 and 1. Call this point C. This is the point 1, 1. This is a square, even though I need to, right, didn't combine. This is the point 1, 0. Let's call this point D. Okay? Okay. This is my receiver operating characteristic curve. Receiver operating characteristic curve. And the point that is the optimum point is this point right here. This is the optimal point. Optimal point. It's the point, the optimal point is the point closest to this point right here, to B. Okay. Now, I want to talk about these 4 points. See, if you like this stuff and you like sports, you can be up in the booth watching all the, actually you are not, you will not be able to watch the football games up there because you must be involved deeply in what you're doing. Because if you watch the game and you don't pay attention to the analytics, in fact, there was a pass thrown by one of the quarterbacks, and that pass had a 13% chance of being caught in the spot where it was, and it was caught. Okay, the receiver caught it, but they automatically put the 13% chance, and he caught it. This is where the big-time receivers do the catch. But a lot of times they want to say, okay, well, if we do this game, if we do this play, what are the chances that it will be caught? And sometimes the coach says, like Belichick is not into that. He goes, screw the analytics. I don't know to what extent he gets into them, but he has, what is that guy's name behind the scenes? Something James? He has a secret person. And Belichick has this guy who can overrule anybody. The last second he says, change the play and do this, because he's using the analytics. I wanted to find out, I called 411 to try to get the number for New England Patriots because I wanted to talk to the analytics person. And the 411 people told me that there's no phone number for the Patriots. I said, what? I went to the website, there's no phone number. But whenever somebody tells me that you cannot find something or you cannot do something, then it becomes a matter of a principle. I know that MIT does an annual conference in sports analytics. I went to their website, and as I was looking around, I found one of the co-founders is a lady that started, and that I wanted to read her bio. In her bio it said she worked for Kraft Sport something. She started a company called Kraft something something. I looked it up. She in fact worked for the Krafts. And she does the business analytics for New England Patriots, Philadelphia 76ers, New Jersey Devils, the hockey team, and some other international associations, right? I sent her an email to invite her here, but that's how the Patriots do it. You cannot reach them via telephone number. You have to email them. Okay, so this is, I want this to be captured. So this is the ROC, this is 0, 0, this is FPR. FPR means it goes from 0 to 1. All these rates go from 0 to 1. This is the point 1, 0, so this is D. this is, so this is A, this is B. You want to write this down and you want to know this. Okay? And this is the point 1, 1. So the best point is the point closest to B. So this is the optimal point. This is, by the way, you also have, it doesn't show here, but you have this line here called the baseline. This is the ROC. If the ROC is close to the baseline, no good. This is doing things randomly. This is like when it was used in World War II. You see a plane, you say, I guess it's going to be friendly. Do you want to do that? You don't guess like that? Or you see somebody, you say, like you watch those 2 videos, this person has cancer without any CAT scan or anything like that. That's the baseline. This is doing things randomly. So you want this line to be well above. This is a better ROC curve. If the curve is below, this is you're doing worse than randomly. So this area here is the area under the curve. This is the area over the curve. You want AUC, right, to go towards 1. And you want AOC to be closer to 0. So the higher the curve, the smaller our AOC is this curve right here. Now, I want to do one means success, 0 means failure. Okay? So this is actual and this is predicted. You want to know this very well. Okay, so here would be TPR, this is FNR, this is FPR, and this is TNR. Okay? Okay, this is point A, this here will be the classification at point B. At point C, 1, 0, 1, 0, okay? So C is 1, 1, and this is D. So this is 1, this is 0, this is 1, this is 0. Okay, always on the left actual, the top is predicted. At point A, where is FPR? Point A. This is FPR, and this is, see, any point here, the x-axis is the false positive rate, and the y-axis is the true positive rate, like x and y, right? So FPR is 0, and TPR is 0. This is where the numbers come from. Now, horizontally, these two have to add up to 1, but not vertically. Pay attention. So if this have to be 1, what's this? 1, and what's this? Okay. Oh, okay, this is A. That's what I was doing. So I'm going to call this B. So B is 0, 1. Okay, so tell me, what is the meaning of this? What does this say? Remember, you go to the hospital, 1 means somebody is diagnosed to be cancerous. 0 means it's diagnosed to be not cancerous. What is the meaning when you look at some graph on the x-rays and they say your results are here? What does that mean? See, here you have you have 1, 1 and 0, 1. What does it say? Everybody is classified as being cancerous. Now, for these people, it's okay. When I say it's okay, right? You know what I mean. Here's the error. So this is half good, half bad. So this point, A, is not a good point. Let's go to B. B has what two values? FPR is 0 and TPR is 1. FPR is 0, TPR is 1. This means this will, so these come from the graph. So this means this is 0 and this is 1. So what does this mean? What does this mean? This means, the one means you have 1 ones, right? People who are cancerous in reality get diagnosed as cancerous, but this other one here means negative, negative, right? Right? So these are percentages. So this, whenever you have this one here and this one, this is 100%, this is a rate. 100% of all cancerous people are diagnosed as cancerous, and this one means that 100% of the non-cancerous people are diagnosed as non-cancerous. This is a rate. So this is the best, because cancerous are identified, are classified as cancerous, non-cancerous, non-cancerous. This is my best point. That is why you want this point to be as close to that as possible. B is the best. So if you are on a graph, okay, and somehow you look at the cutoff point associated with this is the optimal cutoff point. Take the point C. The point C has 1, 1. So remember, each point here, the first one is FPR and the second one is TPR, right? The first point. So this is FPR, this is TPR. So FPR, TPR. So this is like 100%. 1 means 100%. Okay? So, so when you have 1 and 1, that's what it means. All right? So what does that mean? So A was 0 and 0, right? 0 and 0. So let's go back to correct what I said for A. These are the 100%. So A means what? This is plus minus. This is minus minus. So what I said for A was incorrect. So this means everybody is classified as not cancerous. You look, this is 100%, right? So so this is 0% here, 0% here, 100%. So 1 and 1. All cancerous people are classified as not cancerous, and all non-cancerous as not cancerous. This is correct, but this is wrong. When you are here in point C with 1, 1, this means 100%, and this is 100%. And this is 0, this is 0. So this is where you have plus, plus, and minus, plus. Remember, instead of 0, you can put negative. Instead of 1, you put a plus. So this is where everybody is classified as cancerous. And in D, you have the point 1, 0. 1 and 0. Well, if this is 0, this is 1. If this is 1, this is 0. So you look at the ones to explain what's happening. So this tells me, right, that this is you have negative, positive. This says all the people that don't have cancer are classified as having cancer, and all the people that do not have cancer, you can, up here, you can replace the one with the plus, the zero with the minus, the one with the plus, zero with the minus. But here, the zeros and the ones are percentages. Okay? 1 means 100%. So this says all the non-cancerous people are classified as cancerous, and this says all the cancerous people are classified as non-cancerous. This is the worst point. Okay? Notice. Okay. Now, okay. You see what I have done in this Excel file. I have done this ROC, many cutoffs. I did many different cutoffs. I used cutoff equal to 10, equal to 5, equal to 2 to justify the other dots. So you have a dot. For each cutoff point, you create a classification matrix, and then for each cutoff point, you have a dot. This is, you don't want to leave now.
No, I'll go to the bathroom.
This is the high point. I'm going to show you ROC with jump.
Okay.
This is the highlight. Okay, so I have the description here what to do with the mosquitoes example. This is the documentation. And you have all the steps there, but if I open mosquitoes don't jump, you see if I was trying to do this and it would kick me out, I would walk into President Aoun's office. That's how upset it would get me. Okay, so I enter the data this way. You see, this is 0 to 2, the dosage, and this is how many lived. So I have to say lived 34, and this is 0 to 2, died 3. So that's how I have to enter it in jump. From 2 to 4 lived 63. So where is my... You see this, how I enter it? I take it from this format. I have the lived and died. Okay? Okay. The 0 to 2, 34 lived, 3 died. So I put, see the 2, 34, and 3, right? 2 lived 34, 2 lived 34, 2 died 3, right? You see what, that's how, okay. Now, so here you click Analyze Fit Y by X. This is jump. Status goes into Y response, dosage goes into X, and count goes into frequency. You see here on the x-axis you have a numerical, on the y-axis you have something which is categorical. So numerical on the x-axis, categorical on the y-axis. It will give you this curve. We will ignore this curve, but later on when we do the logistics regression, we will talk about this. Ignore this for now. Then you go onto the red triangle and you click ROC curve. and then it says which level is the positive. So for us, success is when a mosquito dies. That's the plus, died. Click OK, and this is my ROC curve, and this is the ROC table. Okay. Now, this file right here, this file, the Word document, has the output. All right? And I show you exactly how to do it, what I did, and what I select, everything that I did, and you see this is the table, and for some reason they like to do things from bottom up. All right, and I don't know why they repeat the last thing. This is 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and so actually the cutoff point 10 corresponds to this line. Here, this is FPR, and this is TPR. Okay, and so this is these numbers actually right here. These numbers right here these numbers right here correspond to the same numbers that I had in this that I had here. So let's put this and that side to side. All right. This has an AUC of 0.84683, and this here has an AUC of 0.86 or something. Okay, here's the AUC, and at the end it says 0.88. The difference is not that big. They're probably using a different way to find the area. But these two, all right, here, if I take this and go into paint and do this, it will be easier to, to have, okay, here is side by side. Here is the resource pack output, and here is jump, and these numbers here, if you look at the if you look at the bottom here, you see the the 0.9355, 0.98, it's this point here. Okay? The next point is 0.8150, 0.8642, 8150, 0.9642. So this go up, this go down, but it's the same numbers. This corresponds to the optimal 0.10, okay? And this is, this happens, this is at cutoff point, I said 12 here, but it's 10, all right? And so here is the ROC, and this line right here is the tangent to this point, okay? And next time I will, well, actually, let me write this down. Hello. I want you to know, where's my erase? When you have these matrices, right, you can also calculate the following statistics. Precision is TP over TP plus FP. F1 score is 2 times precision plus, oh, I'm sorry, times recall over precision plus recall. Recall is sensitivity. G is the geometric mean, and all of these have usages, and this is the square root of precision times recall. I want you to know this. Okay. Positive likelihood ratio. This is TPR over FPR. Negative likelihood ratio is FNR over TNR. False positive, this is the same as in statistics, the type 1 error. And this is when you reject the null when the null is true. If you do a null hypothesis and an alternative hypothesis, and the null is that you are healthy, meaning 0, and this is that you are sick, meaning 1, then FP is the type 1 error, false negative is a type 2 error. Okay? And this is when you fail to reject the null when the null is false. All right? So, I want you to know this.